Hello student, in this video we will study the recurrence relation between the probabilities of geometric distribution and distribution function of the geometric distribution. First we see the recurrence relation between probabilities of geometric distribution. Okay, if x follows geometric distribution with parameter p, then its probability mass function is given by probability of x equal to small x, which is equal to p into q raised to x. X takes values 0, 1, 2, dash dash dash, 0 otherwise. Okay, this is the probability mass function of geometric distribution. Then probability of x equal to x plus 1 is equal to p into q raised to x plus 1. Here x takes value 0, 1, 2, dash dash dash, 0 otherwise. Okay, now we take ratio of probability of x equal to x plus 1 upon probability of x equal to small x. Ratio of probability of x equal to x plus 1 and probability of x equal to x, which is equal to p into q raised to x plus 1 divided by p into q raised to x. pp gets cancelled, q raised to x gets cancelled, which is equal to only q. Okay, therefore probability of x equal to x plus 1, which is equal to q into probability of x equal to small x. Here x takes values 0, 1, 2, 3, so on. This is the recurrence relation between the probabilities of geometric distribution. Okay, if we know the probability of x equal to 0, which is equal to p, if parameter p is known, then we will get the probability of x equal to 0, which is called as the initial probability. If initial probability is known, then the further probabilities can be computed using this recurrence relation. Means if x equal to 0 is equal to p is known, then probability of x equal to 1 can be computed using this relation, that is probability of x equal to 1, which is equal to q into probability of x equal to 0. Then probability of x equal to 2, which is equal to q into probability of x equal to 1. In this way we can obtain the probabilities of geometric distribution using this recurrence relation. Okay, now we see the distribution function of geometric distribution, or it is also called as the cumulative distribution function. Cumulative distribution function in bracket C D F, cumulative distribution function or simply distribution function or distribution function df in bracket df. Okay, now for the random variable y follows geometric distribution with parameter p, then its cumulative distribution function is given by f of y is equal to probability of y is less than or equal to small y, which is equal to summation of p into q raised to r minus 1 summation over r running from 1 to y. This is the cumulative distribution function of geometric distribution. Now, which is equal to p is constant, take out of summation sign, then write down the terms in the bracket, put r equal to 1, then the first term is 1, then put r equal to 2, second term is q, then q square plus q cube plus so on. Okay, now the bracket, the terms in the brackets are the which is the sum of the geometric sum of the first x terms, which is the geometric progression, then with first term is 1 and common ratio q, therefore f of y is equal to p into 1 minus q raised to y upon 1 minus q, which is equal to p into 1 minus q raised to y upon p. 1 minus q is equal to p, since p plus q is equal to 1, this p gets cancelled, which is equal to 1 minus q raised to y. 1 minus q raised to y is the distribution function of geometric distribution. Therefore, f of y is equal to 1 minus q raised to y. Here y takes values 1, 2, 3, 4 dash 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 dash. Okay, now this distribution function can also be written as f of y is equal to 0 if y is less than 1, is equal to 1 minus q if 1 is less than or equal to y less than 2, equal to 1 minus q square if 2 is less than or equal to y less than 3, and so on. This is 1 minus q raised to y if this y is greater than, which is equal to 1 minus q cube if 3 less than or equal to y less than 4, okay, and which is equal to 1 minus q raised to y, okay. If write down here, this is r if 1 less than or equal to r less than y, okay, means this distribution function can be written in this way. Now we obtain the, or we see the lack of memory property of geometric distribution as follows. Lack of memory property of geometric distribution, okay. Suppose capital X be a discrete random variable having geometric distribution with parameter p, then it possesses the lack of memory property, and its statement is given by probability of this y is greater than or equal to, or this y is greater than s plus t, given y is greater than s, which is equal to probability of y is greater than t. Here s and t are the positive integers. S and t are the positive integers, okay. Now we prove this one. Proof. We know that distribution function of geometric distribution is f of y is equal to probability of y is less than or equal to small y, which is equal to q raised to y. Here vertex value is 1, 2, 3, 4, so on, okay. This is the distribution function of geometric distribution. Now probability of y is greater than small y, which is equal to 1 minus probability of y is less than or equal to small y, that is 1 minus f of y, and f of y is equal to 1 minus q raised to y, which is equal to 1 minus, in bracket, 1 minus q raised to y, then which is equal to q raised to y only. Probability of y is greater than small y, which is equal to q raised to y only, okay. Now using this we can find the probability of y is greater than s plus t, given y is greater than s. Now we consider the left hand side of this statement, okay. Consider probability of y is greater than s plus t given y is greater than s, which is equal to probability of y is greater than s plus t and y is greater than s, this whole divided by probability of y is greater than s. Okay, by using definition of conditional probability, this probability is equal to this one now, which is equal to probability of y is greater than s plus t upon probability of y is greater than s. Okay, this probability is equal to, now this is q raised to s plus t. Okay, this divided by q raised to s, q raised to s, q raised to gets cancelled, required probability is q raised to t. Okay, this is the probability of y greater than s plus t given y greater than s, which is equal to q raised to t, and probability of y is greater than t, which is equal to q raised to t. This is from this statement, the left hand side of this statement is equal to the right hand side of this statement, that is q raised to t is equal to q raised to t, means both probabilities are the same. Hence the proof of lack of memory property of geometric distribution, this is the proof. Okay, thank you.